Good morning, Tahmina Khan is here in TKMaths S1. In today's video, we will solve a question of M1, which is a part of the syllabus of A-level mathematics. Code is 9709, paper is 42, and it is February-March 2024. So this question you can see is straight away from the topic calculus, where the velocity equation is given to you. You can see it here, and they are saying you may assume that the velocity of the particle is positive for t less than half. At t equals to 0, it is half, it is 0, and is negative for t is greater than half. So without solving a question, if I want to recall the sketch in my mind, because for a better understanding, deep understanding, you need to understand the sketch. So the coefficient of t cube here is positive, which is 1. So the shape of the graph will be like this, right? And with the help of this information, what I'm getting is that the particle is, the sketch will pass through half, right? And less than half, the curve is somewhere here, and greater than half, the curve is somewhere here, right? So this is a rough sketch coming into my mind. Immediately I read the question. And second thing is, I will recall in this topic that when I differentiate displacement equation, I get velocity. When I differentiate velocity equation, I get acceleration. And since it is integration is the reverse process, so if I integrate acceleration, I get velocity. If I integrate velocity equation, I get displacement equation. So this is what will come in my mind immediately. And we are talking about the sketch between 0 to 4 seconds. And because it is time, so nothing will be taken off the left hand side, because time is negative. So we are not considering, we are talking about 0 onward. So if I put t0 here, what do I get? 1. It means the curve will be something like this. This side of the curve we are not talking about. Okay, so this is how you get the basic information if you know all the key aspects of the graph. So I have to find the distance traveled between t0 to t half. So one method is that you straight away integrate the velocity equation and apply the limit 0 to half on it. So let me explain that first. It's a basic integration because there are 3 terms: t cube, t square, and constant. So integration, and for the integration, the basic thing is that you add the power and divide by the added power. You know that thing. So I have done exactly the same thing, and after that I have applied the limit. But before applying the limit, what did I do? I have simplified it, because it is always recommended to simplify your terms and then apply limit. And one more recommendation: do not straight away do everything in the calculator. Show your important step, so the maximum marks you can get even if you make mistake in the last step of calculating the answer, because the rest of the thought process will be clearly indicated. That will show you have knowledge of everything. So according to marking scheme, you may get marks there. Now one thing I would like to say here, the thought should come into your mind that will I take 0 to half straight away or not, right? Though it is a very clear cut question, but sometimes there is a trick in it. So with respect to that, I'm talking about when we put velocity 0, right, v0, like I have done it here for you, what I'm getting: time 4.44, half, and 0.449. What does it mean? It means these are the 3 points where the curve is passing through the x-axis, right? Let me just explain it to you, where it will be a tricky question. You will be able to handle it. So this is clearly shows that the curve is passing through these points on the x-axis. So it is something like this. And when question is saying 0 to 4 second, it means I'm talking about from here till 4 is somewhere here. So I'm talking about only this part of the curve. So the moment you put v0 and you get time, you will immediately understand the part of the graph they are talking about. And when I said 0 to half, it means this is the curve which is between curve and the x-axis, so I can integrate it. There is no turn in between, so it will not affect my calculation. Okay, what did I do here? Why did I differentiate it? I'm differentiating velocity equation y. That we will discuss in part 2 also. So let's go there. Achha, by the way, I have done here part A by another method. What students usually do, rather than applying limit directly, they integrate the equation, right? And this limit was not there in that case, sorry, right? And then they get C. After that, they apply the values which are given to them in the question, S0, T0, to find out the value of C. And how did they get this information? From the first line of the question, which is here. Starting particle starts from a point O. Oops. So this is a long method, but I have seen students working by that method also. So I wanted to tell that it is possible, but then they are penalizing themselves by taking more time. So it's better to do the first method by taking up limits straight away over there. So let's come to part B of the question. Find the positive values of t at which the acceleration is 0. So I have just sketched the graph for you, and I differentiated it. This bar graph is hiding the information. I want to move it so that you can see it clearly. Yes, it's better, right? So I have differentiated here. Whenever you differentiate the velocity equation, you get the acceleration equation. And when question is saying at which the acceleration is 0, it means you will accelerate, differentiate it and put it equals to 0 to get the time. Agreed? Now what is the meaning of this? When you get time 0 and 3, what does it represent? So on the right hand side, I have done a sketch for you to explain it to you, that at t equals to 0, which is here, and at t equals to 3, which is here, the rate of change is 0 because it is a turning point. And you have to find out what? You have to find the positive value of t at which the acceleration is 0. We have found it here. And then you have to find the total distance. This is an important thing. Between 0 and this instant. So this shaded portion which I have done here, you have to find out this. So mistake happen here after getting this value. What mistake students make? They straight away apply here the limit 0 to 3 and find it out, because the sketch is not there in front of you. I have done here for your better understanding. But the problem here, you have to remember or connect it with part 1, where it was given to you that 0 to half it is positive and then greater than half it is negative. You see, this part of the curve is below the x-axis. So velocity is negative here. Your y-axis is actually your velocity. So hint is given there, but you have to make connection and understand it. So 0 to half, you have already calculated this area, this distance, because in the velocity time graph, the area under the curve gives you the distance. So now what you will do? You will only do from half to 3. Yes or no? So this is what I have written here, that 0 to half second distance you have already calculated. So now you will do half to 3 and not 0 to 3. Don't make this mistake because it is split into 2 parts. So you can't go do it in one go. And that is the reason I have taken here half to 3. Another very important thing, you get answer is minus. What is the reason for that? Because it was below the x-axis. So if you remember the integration, in P1 you have learned this thing. Okay, whenever the curve is below the x-axis, you write minus sign outside and then you integrate it. So in this case also, if you keep minus sign outside, automatically it will come plus. But doesn't matter, if you have not, you can write at the end without it the value only, because we are talking about distance, right? So thank you very much for watching the video. In the next video, I will explain the question 6 of the paper 2024. So you can see the link in the description below. Thank you very much. Take care. Allah Hafiz. Don't forget to press like and subscribe button.